So the final presentation is on wildfires in Angola and the correlation of vegetation and meteorological variables with wildfire intensity. So this was a team of Agnesa Karapetian, Camille Blasek, Carolina Temporaro, Marquez Felipe, Hatis Busragobunar, and Sedem Balbasa. I'm sorry if I mispronounced any of those. And the mentor was Brittany Engel. So take it away, whoever's doing this one.
Hello, everyone. Thanks for having us here. We will indeed talk a bit about wildfires in Angola and our idea of do a correlation of vegetation and meteorological variables with wildfire intensity. And why wildfires, I think, is pretty intuitive that wildfires pose significant risks to life and have considerable social, environmental, and economic impacts. And Africa is by far the most affected continent, with around 70% of the global burned areas being located there. As you can see in this plot that refers to the most recent decades, you see that is very clear that this is the case. Well, according to the IPCC report, over the last century, climate conditions promoting wildfires have become more probable and will likely be more frequent at higher levels of global warming in some regions. So considering the urgent need for wildfire adaptation and mitigation strategies, it is obviously imperative to identify the factors that contribute to wildfire intensity. Well, potential factors are the levels of vegetation health and density before the wildfire, or in simpler terms, the greenness of a landscape. And this is, as we already heard, this can be measured by the normalized difference vegetation index, so NDVI, and other, like apart from this vegetation variable, meteorological variables such as temperature, precipitation, and wind speed are known to have the potential to influence wildfire intensity. So here in this project, we aim to investigate the relationship between these vegetation and meteorological variables with wildfire intensity. So we defined wildfire intensity as an umbrella term that encompasses wildfire duration, the burnt area, and the severity of a wildfire, which is measured by differentiated normalized burnt ratio, DNBR, which we will touch a bit more later on. So specifically for this aim, we collected data from 4 data sets. First of all, we used the GlobeFire dataset, which is a subset of the Global Wildfire Information System, to collect descriptive information about wildfires, namely the duration and the burnt area. And with this, we did a selection of the wildfires that we will talk a bit later on. Besides, we use satellite data images from the MODIS surface reflectance 8A product. And with this, we calculated the pre-fire NDVI, and we, by comparing also the post-fire NDVI, we estimated wildfire severity by calculating the DNBR. Then we used Area 5 land for temperature and wind data, and lastly, this data set for precipitation data. And now I'll pass the floor, the mic to Agnesa.
So to further narrow down our analysis, we selected only the wildfires in one specific country, Angola, because it is a country that is the most affected one in the world, or at least in the time period that we selected for analysis. So as you can see, Angola, the fires in Angola accounted for over 11% of all wildfires on Earth. Then we wanted to look at which vegetation types are affected in Angola. And we focused on 3 main vegetation types. So forest, herbaceous vegetation, and shrubs. And as you can see, those were the most affected vegetation types in Angola. And of course, we couldn't look at all 12,000 fires in Angola in 2020. So first we narrowed it down by year. So we only selected fires from 2020. Then we saw that there was over 12,000 wildfires in 2020, and this would be way too computationally expensive. So we selected only the 50 largest wildfires and performed our analyses on these fires. And this image doesn't show you the size of these fires, but simply shows you the distribution of the fires. So we can see that the forest fires occur mostly in the east and in the south in blue, and the herbaceous vegetation fires occur mostly in up north, while the shrubs happen rather at the extremity, so at the north and at the south. So to select the data in terms of space, we selected the rectangles that corresponded to the extent of every fire in terms of longitude and latitude. And then using these rectangles, we computed the temperature, precipitation, wind, NDVI, and DNBR values within these rectangles and averaged over them, such that we obtain one value per year for all of these variables. So these are the examples of the values that the NDVI and DNBR values that we extracted from our satellite data using the MODIS product. So on the left, we see the NDVI, the pre-fire NDVI image for the second largest wildfire of Angola. And on the right, we see the corresponding DNBR value for the same fire. So what we roughly can qualitatively just by visual inspection see is that the areas which have a larger NDVI that are greener also correspond to the areas that are most severely affected by wildfires. So the green stuff here is represented by the orange stuff here. So this already kind of indicates to us that there might be a correlation between the two variables. But of course, to look at it from a more quantitative perspective, we correlated between all these different variables, so between the variables corresponding to the wildfire intensity and with our meteorological variables. So in blue, we have the variables corresponding to wildfire intensity. In yellow, we have the correlation between these variables and pre-fire NDVI. And in green, we have the meteorological variables. So we only indicated here the significant correlation. So we left out everything that wasn't significant, which is why there's a lot of white space. And basically, from this correlation matrix, we have 3 main conclusions that we could draw. So first, we saw that there was a correlation between all of these wildfire intensity variables. So to summarize this, we can say that longer and more severe fires were associated with more burnt area. And further, with the pre-fire NDVI variable, we also saw a positive correlation between the pre-fire NDVI and the DNBR, which indicates fire severity, and burnt area. So this suggests us that the greener the area, the stronger the fire, and the higher the burnt area of a wildfire. And lastly, for the meteorological variables, we didn't see any correlation between them and the wildfire intensity variables, but we saw that windy days were colder. Then moving on to shrubs. So previously we did this for forests and we did this for shrubs, and we see a very similar picture emerging. So we again have a positive correlation between some of the wildfire intensity variables. So here only between burnt area and fire duration. And we again see that pre-fire NDVI was positively correlated with DNPR. So once again, we have the same conclusion that greener areas are correlated with more intense fires. And again, for the meteorological variables, windy days were colder and the fires were also shorter. So here we actually do see a correlation between one of the wildfire variables. So fire duration was actually shorter when speed was higher. And lastly, for herbaceous vegetation, once again, a positive correlation between the wildfire variables, the wildfire intensity variables, positive correlation between pre-fire NDVI and DNPR and fire duration. And again, windy days are colder, fires are shorter and less severe when there's more wind. So overall, the picture that emerges from these analyses is that a higher pre-fire NDVI was correlated, which we can summarize or colloquially define as greenness of an area, was correlated with the wildfire severity and wildfire duration. However, wind positively correlated with wildfire severity and wildfire duration. Whereas for one specific meteorological variable, wind speed, we had a negative correlation. So less wind speed meant longer duration of a fire and a more severe fire. So overall here, of course, we only used correlations. Ideally, in the future, these variables could be combined in predictive models such that we could actually predict how fires would take place, and we could identify areas that are more prone to intense wildfires, such that we could mitigate them and respond to them as quickly as possible. So we just wanted to acknowledge the rest of our team who can make it here today, as well as our mentor, Brittany Engel, for the immense help and comments that she provided to us. And of course, the Climatematch impact organizers for a wonderful summer school and project development time. Thank you.
Great, thanks. That's really interesting. Do we have any questions? Douglas?
Yeah, very interesting work. And one thing, when you look at NDVI, is that have you also looked at the drought conditions before the fire? Oftentimes that the greenness information combined with drought may gives you more information because the drought condition makes it more prone to the fire.
Yeah, you're right. And we didn't look at the drought condition. We really just looked at the closest dates, that the data for the closest date before a fire that we had. And that kind of just gave us one image, and we calculated the NDVI based on that. So we don't really know what the situation was even a month or 2 months before the fire. So we really looked at 1 day, 2 days before.
Okay, great. Yeah, might be something you can look at into the future, having a more like, I guess it's the compounding between the drought and the vegetation.
Mm-hmm.
Yeah, Abigail?
Yeah, hi, this is really cool work. I think I don't know if I missed this in the beginning if you said it, but did you take all of Angola as a whole, or did you do some regional distribution in terms of in terms of fires and the plantation?
So what we did is that we selected so we split Angola not in terms of regions, but in terms of vegetation. And if I remember it correctly, and then we took for every type of vegetation, we took the 50 largest wildfires. So that would mean that likely for example, for forests, you know, the fires come probably somewhere from this region from the east. For herbaceous vegetation, probably from up north, and for shrubs probably down here. But we didn't specify, we didn't select specific regions. We just kind of sampled the top fires all over Angola.
Yeah, so that could be a nice step towards, connecting with policymakers and in the mitigation part is to kind of relate regional distributions of the vegetation to the actual I don't know what the word I'm looking for, like governmental regions in Angola and see kind of how that discussion can get going. But this is
Yeah,
really cool.
for sure. Thanks.
Yeah, thank you.
I wanted to ask about oh, go on, Courtney.
I just had a quick question. I live in like the Western US, so we have a lot of wildfires too, and we always see wind as a higher risk factor, usually that make fires like worse. I'm curious if that was like a surprising outcome for you, or if there was something else about the specific location that would make wind decrease the intensity of the fires. Unless I misunderstood that, but that's what
No, yeah, I think we also were kind of surprised by that. Right, Carolina? Because we also would expect that more fires would lead to like faster propagation, more wind would lead to a faster propagation of the fire. So we think that there's maybe a third variable involved in there. We also are not sure how windy Angola actually gets. So we might be working with a very small range of wind. So, but you're right that we also would expect that finding. Yeah, we'd have to dig deeper to see really what is happening there.
Yeah, I was going to ask the same question, but I was wondering now if, because you didn't look at burnt area related to wind, right? I wonder if, is it because you're looking kind of at individual locations and the fire maybe moves very quickly out, so it's like they're short duration and not that intense, but maybe they're covering large areas? Is that a possibility?
Yeah, that's true. That could be because we really only looked at, the data also comes from different data sets. So we tried our best to kind of map the dates because we don't always have a great resolution for these data sets in terms of time. So it's also possible that there could be, that it's not specific enough. But yeah, it was also a surprising finding for us.
Yeah, I would also like to add that a big limitation of this is that we don't know the nature of the wildfire. We don't know if it is natural or if it is human. Yeah, the source was human. So, we are using these meteorological variables, but without knowing these, it's a bit, blind for us. And if we would get this information, it will be amazing if we could access to this kind of information here.
Yeah, I could see how that could be tricky because presumably humans are less likely to light fires on windy days. So it's probably not, they're probably not randomly distributed in terms of the wind. But yeah.
Exactly.
Any other questions? All right. Well, and those are 3 great talks. Courtney, are you going to close us down, or yeah?